Okay, now I'm going to type in a different one, negative x cubed. Realize that the n, or the exponent, is still odd, but this time the a, the coefficient, is negative. And according to that second rule that we have, it states that it's going to be in quadrants 2 and 4. So let's see if that is true. Let's see if that is true. Yes, it does seem like it's going to be true. So now you see why I'm only giving you the foundation, because if you know the line, or if you know the parent function of a line, the positive direction and the negative direction, you should be able to apply those rules to anything that is odd powered. Now let's go ahead and move on to the last two rules, and I want to talk about the foundation for that one. So let's see. Let me erase this part here. And I'm still going to have the same generic equation, a times x to the nth power. So if we started off with the foundation for odd being a linear function, what do you think we're going to start off for our foundation for even powered functions? What's the function what's the parent function we have been studying this past week? The quadratic parent function. That's exactly right. So now I'm going to be looking at f of x is equal to, or in other words, y equals to x squared. And we all know that there is a coefficient of 1 right there. So a is 1 in this case, n is 2. So we all know, if we look at our calculator, what the parent function of x squared is. It's a parabola that is opening up. Let's see if that's true. That is true. What do we notice? What two quadrants is it in? Quadrants 1 and 2. So let me write those down. Quadrants 1 and 2. Alright, and let's go ahead and classify our n, our exponent. Our exponent is even. And let's classify our a, which is the coefficient, in that it is positive. So a is greater than 0. So what can we say about even powered functions that has a coefficient that is positive? It's always going to be in quadrants 1 and 2, starting and ending in quadrants 1 and 2. 1 and 2. Alright. So that confirms the third rule right here. If n is even and a is greater than 0, in other words positive, then f of x will end in quadrants 1 and 2. Alright, so now let's go ahead and do that fourth one. And I'm going to clear this out. And the only thing that I'm going to do for this fourth one is attach a negative in front of that 1. Because this is a parabola now that is opening in which direction? It's opening down, and I do hope that you know which direction it's opening, because you were just quizzed on it yesterday. Alright, so let's just confirm. Is it opening down? It is. It is opening down. A parabola that is opening down, and we can also see that it's in quadrants 3 and 4. So let me write those down. Quadrants 3 and 4. 3 and 4. What can we say about n, the power or the exponent? N is even, of course, it still is. But this time, what can we say about a, the coefficient? A is negative. In other words, a is less than 0. So if we have even powered functions, but the coefficient is less than 0, in other words negative, it's going to start in quadrants 3 and 4. 3 and 4. So let's check. Let's just try it. Let's do x to the 8th power. I don't know how big that's going to be. We know that if we follow those rules, 8 is even. The coefficient of 1 is positive, so it's going to be, you got to think, okay, even. Go ahead and think parabola. Is it opening up or down? Well, in this case it's positive, so it's opening up. So we think a parabola opening up, that's quadrants 1 and 2. We expect x to the 8th to do the exact same thing. Let's check. That's completely true. All right, so now let's do x to the 6. Let's do x to the negative x to the 6. So again, automatically you see even, think parabola. Now you got to say opening up or down. Well, it's opening down because of the negative. So we're automatically thinking of parabola, opening down, quadrants 3 and 4. Let's see if that's true. It is true. So again, I want you to only focus on the foundation. If it's odd, think of a line going in the positive direction or the negative direction. If it's even powered, think of a parabola opening up or opening down. Up if it's positive, down if it's negative. All right. So hopefully that is a better understanding of all of these rules. And again, these are all of the directions that we have. The first one starts and ends somehow or another in quadrants 1 and 3. That's the first rule. The next one, quadrants 2 and 4, that's the y equals negative x. The one here on the left-hand side is a parabola. Again, pretend that you see a parabola opening up, quadrants 1 and 2. And then the last one, think of a parabola opening down, quadrants 3 and 4. Very easy things. Again, you know these. You just probably didn't realize that you did. All right, let's see. What quadrants will the following functions finish in? One thing that you must keep in mind is that you always want to look at the highest exponent. You're always looking at the highest exponent. That term, that area. That's what we're interested in. Now, you got to be careful because I may not necessarily always put the highest term with the highest exponent at the front. I could give it to you at the end. I could place it to you in the middle. Place it for you in the middle. So you have to make sure that you are identifying the term with the highest exponent. So let's take a look at this one. Here we go. F of x is equal to negative x cubed plus 4x. Okay, this right here, this entire thing, that's what I'm going to be looking at. Let's look at the exponent first. The exponent is 3. All right, go to your foundation, 3. You're going to think of a line going in the positive direction or a line going in the negative direction. Well, positive and negative depends on the coefficient. Right here, what is it? Negative. So we're thinking of a negative line, and what quadrants are those? Quadrants, what? 2 and 4. Quadrants 2 and 4. Let's see if we are right. There we go, quadrants 2 and 4. Now what I want to do is I want to type this into the calculator so that you can actually see. So we have negative x cubed plus 4x. Let me type it in for you. Negative x cubed plus 4x. We said quadrants 2 and 4. Let's see if we are right. Yes, we are. It starts and ends. I don't know where starting or ending is, but all I know is that it starts and or ends in quadrants 2 and 4. That is true. All right. Now, let's take a look at the next one. X to the 4th minus 5x squared plus 4. Highest exponent term is right here, x to the 4th. All right, here we go. Even or odd? 4 is even. Okay, automatically think your foundation. A parabola opening up or a parabola opening down. Up if it's positive, down if it's negative, depending on the coefficient. Well, let's look at the coefficient right here. It's positive. So we think a parabola opening up. What quadrants does the parabola live in? Quadrants 1 and 2. Let's see if we are right. Very good. Let's take a look at the next one. F of x is equal to x to the 5th minus x. X to the 5th minus x. Highest exponent term, right here. Right here. Okay, let's look at the power or the exponent, even or odd. Odd. So we automatically think of a line going in the positive direction and the negative direction. Now you got to figure out, well, is it positive or negative? Let's look at the coefficient. It's positive, so we think of a line going in the positive direction, which is the linear parent function, and that's going to be in quadrants 1 and 3. All right, and the last one on this slide is negative x squared plus 4x minus 7. This one is easy because the highest exponent is what we just studied right here, quadratics, and we automatically think of parabola opening up or opening down. Up if it's positive, down if it's negative. Okay, we look at the coefficient, it's negative, so we think of parabola opening down, quadrants 3 and 4. There we go. Very easy to figure out. Okay, let's move on. It says a zero of a function f is an x value for which f of x is equal to 0. In other words, zeros are the x-intercepts or solutions of the polynomial. I don't remember if I've mentioned to you, but I'm going to write it down for you. I'm going to write it down for you. All right. X-intercepts. X-intercepts. Zeros. Roots. And solutions, they all mean the same thing. They all mean the same thing. And you may not know what a solution, a root, let me put an S here. You may not know what solutions, roots, zeros are, but you do definitely know the most important one, which is the x-intercept. And you know what is always true at the x-intercept. That y is 0. So whenever I'm going to be going back and forth and I'm going to be using any of these words, I could be saying x-intercepts, zeros, roots, solutions. You should know that they all mean the same thing, and that means that y is equal to 0. Y is equal to 0. So let's go ahead and work out a problem. I want you to write that down for me. And we're going to do the example there. It says find the real zeros of f of x equals x cubed minus x squared minus 2x. So I'm going to give you a couple of seconds to write it down, and then we'll actually start it. All right, it says to find the real zeros of f of x equals x cubed minus x squared minus 2x. Again, zeros mean the same thing as x-intercept. Intercepts mean the same thing as solutions, mean the same thing as roots. But one thing that I do want you to remember is the following. First of all, let's do a little brief review. Let's identify what quadrants this polynomial starts and ends in. So let's go to the highest exponent term. So that's this part right here. Is the 3 even or odd? It's odd, so automatically go to your base foundation or your foundation, which is a parent function, linear parent function. And it's going to be a positive line or a negative line. In this case, it depends on